Graph the following, find all the key features. So the same key features that we've been doing. What should we start by doing? Factors. Get the top and bottom factored. Bottom is definitely easy factoring. What are my two easy factors on the bottom? Two numbers that you multiply a -3 but add to 2.
X minus 2, X
Minus
minus
2 and minus 1? I don't think so.
minus 3 minus 1.
There. Nope, still wrong.
3 minus 1 plus 3.
-1, +3. Yes, -1, +3. Double check, would these two numbers multiply a -3? Double check. Right, would these two numbers add to +2? Yes, okay. On the top, what should we do first? Yes, take out a GCF. What is the GCF of that? 2x. If I take out a 2x, that would leave me with x squared minus 9. Okay. And then does it factor any more? Yes, it is a difference of squares. So I'll still have my 2x, and then what would that difference of squares be? Very good. Okay, looking through there, we should now be able to see, are there any holes in the graph? Yes. Holes. There is one. What is its x value? -3, right. As you can see, the x plus 3 would cancel. So the hole has an x value of -3. And then before I move on, I'm going to write out the new function so that I'm not tempted to use the old function. Okay, so the new function, it's still y equals, what's still on the top? 2x. And also x minus 3. And then on the bottom we still have x minus 1. Okay, I'm going to scratch out the old one so that I'm not tempted to use it to find anything, not a single thing. Alright, so how do I find the y value of the whole? Plug in -3 to this new and improved function over here. So on the top we'll have 2 times -3, which is -6. We'll have -3 minus 3, which is -6. And on the bottom we'll have -3 minus 1, which is -4. So that's 36 divided by -4. That does divide evenly. What is that? -9. Alright, so there's the y value of the hole in the graph. What's next do we need to find? Vertical asymptote. Remind me, how do we do that again? That's where your denominator is 0. Denom equals 0. How many factors do we have in the denominator? Just one, right. It's no longer this original one. If you forgot to scratch out the original, scratch it out, because when you have the original, it still looks like there's 2. But once you have the new one, there is just 1. When x minus 1 equals 0, so that vertical asymptote would be at x equals 1. Good job. Okay, got that. What else do we find after that? Horizontal asymptote, or it might be slanted, so I usually refer to that as an end behavior asymptote. Okay, and then remember, we're looking at the degree for that. Our acronym was bigger on bottom, 0, Bobo. If it's bigger on top, it's slanted. But if the exponents are the same, we want to divide our coefficients. What is the degree on the top? 2, yeah, because there's 2 x's. Yeah, x and x. What's the degree on the bottom? 1. So, which one is that? Bigger on top. It's bigger on top. So we know it is slanted. How did we find that slanted asymptote again? We divide, yes. So still using our new and improved reduce function. I do need to write this back in standard form though in order to do the long division. So basically just take that 2x and distribute it back. If I take the 2x and distribute it back, what would that give me? 2x squared minus 6x. Very good. Alright, doing our little bit of long division here. Let's see, first term outside, first term inside. We got an x, and we want it to be a 2x squared. What do we multiply by? 2x. Good. So remember, we'll take that 2x. We're going to multiply off the side. 2x times x is 2x squared. 2x times negative 1 is negative 2x. And then what do we do to these terms? What happens to them? First two cancel, but what do we do to the second two? Subtract. And then right here is the most common mistake on just basic subtraction. Negative 6 subtract negative 2 is negative 4. Yes, negative 4x. See? Most common mistake. Okay, and then let's do one more round of division because I still need an mx plus b right here. So I have this x. I need it to be a negative 4x. What am I going to multiply by to get x to be negative 4x? Negative 4. Very good. And you can stop right there. If you want to finish the multiplying, you can. But all we needed was enough to get a slope and a y-intercept. So my slanted asymptote equation is y equals 2x minus 4. Okay. What did we learn yesterday? What was our new key feature for yesterday? Does it cross? Does it cross? Right, that was our new key feature. Let's figure out, does it cross? Okay, so we're going to take what we just got for the slanted asymptote, or if it was horizontal, you would take the number of the horizontal. And I'm just going to take the 2x minus 4 part of it, not the y equals. 2x minus 4. And I'm going to set that equal to my function. But which part of the function? The original? This one that I crossed out? No, because we shouldn't be using that for anything. We should only be using this one now. So I'm going to set it equal to this function right here, which on the top we know, we already multiplied it out. We knew it was 2x squared minus 6x. And on the bottom it's x minus 1. And then we have to solve this. What would I do first to solve? Yes, multiply by the x minus 1, get that denominator to cancel. Which does mean we'll have to FOIL on the left side. Let's see, x times 2x, that's 2x squared. X times negative 4, that's negative 4x. But then I'll have a negative 1 times 2x, which is a negative 2x. Negative 4x minus 2x would give me a negative 6x in the middle. And then negative 1 times negative 4 would be a positive 4. And on the right, I just have what was left in the numerator, 2x squared minus 6x. Okay, what happens to the 2x squareds? They cancel. What happens to the negative 6x's? They cancel. What are we left with? 4 equals 0. Does it? No. What does that mean? It doesn't cross. Right. We got no solution, which means it doesn't cross. Doesn't cross the slanted asymptote. Okay, what else do we still need to find? X and y-intercept. Right, that was the last thing. X-intercept, that's when which variable is 0? Y, or technically our g of x. When y is 0. Was there a shortcut for that? Just use the top, right, because if you make the y 0 and then multiply by the denominator to cancel it, you're just going to have 0 equals the numerator. 0 equals the numerator. How many x-intercepts are there going to be then? 2 x-intercepts. One when the 2x is 0, and one when the x minus 3 equals 0. So one is at 0, and the other is at 3. Sorry, we're running out of room on this problem. I think I have just barely enough room. 0, 0, and 3, 0. And then y-intercepts. How do we find a y-intercept again? Plug in x equals 0. Very good. Plug in x equals 0. So I would have 2 times 0 on the top. I can already tell the answer just based on that. 2 times 0. And then we'll have 0 minus 3, which is negative 3. And then on the bottom we'll have 0 minus 1, which is negative 1. All that's going to turn into is 0, because we have a 0 on the top. We should have known that already, that the y-intercept was going to be at 0. Why? Because the x-intercept was also at 0. If one of them is at 0, the other one has to also be at 0. Okay. Only thing I'll warn you about when you graph this, guys, is the x-axis counts by ones. Like I only labeled every other line, like 0, 1, 2, 3, 4. But what does the y-axis count by? 2. So be careful of that whenever you're graphing your numbers. Y-axis counts by 2s. Okay, let me see. I got a vertical asymptote at x equals positive 1. Vertical asymptote at x equals positive 1. Okay. I have a slanted asymptote at y equals 2x minus 4. So what's the y-intercept on 2x minus 4? Negative 4. Good. And then a slope of 2. Technically, every line counts by 2, so technically I'm just going up one line and then over 1, up one line and then over 1. It's a little tricky with that scale being different on the y-axis. It looks like a slope of 1, but only because the y-axis counts by 2s. Okay, it is still an asymptote, so I am still going to connect it with a dotted line. Dotted line. Okay, and then we have some points to put on here. We have a hole in the graph at negative 3, negative 9. Negative 3 would be right here. Negative 8 is here, so negative 9 is halfway in between the two. Negative 3, negative 9. And then I have an x-intercept at 0, 0, and a y-intercept at 0, 0. And then another x-intercept at 3, 0. 1, 2, 3. Remember when we were talking about slanted asymptotes, I mentioned that the graph's only going to be in two different parts of the graph. So it might be in this wide open area, or it might be in the pizza slice area. And according to our points, this one is in the wide open area. Very good. Wide open area. Beautiful. Alright, I'm going to do the domain and range, just because it's tricky on this one. Remember, I do prefer set notation for domain and range. Domain, range. Okay, let's think about the domain for a second. Remember, domain is left to right on the graph. Okay. Obviously, the vertical asymptote is not going to be included. Okay, because there's that. We definitely don't have an x value at this vertical asymptote. Is there any other place where we don't have an x value? The whole, right. So when we exclude different numbers, we're going to say x is a real number. X is in the set of real numbers, except it's not the vertical asymptote, which was at what number? 1. And it's also not the x value of the whole. What was the x value of the whole? Negative 3. Feel free to label why we did that. This one was the VA. This one was the whole. And then range. So usually for a slanted one that's in kind of this wide open area, it looks like it goes up and down forever. So it looks like it would be all real numbers. Up forever, down forever. But we had that hole right here. So what would be our one number we're going to exclude from the range? Negative 9. Y is in the set of real numbers, but y is not negative 9. Every other y value does exist, because it does, if we look at the branches, they go up and down forever, just not that one little whole value. Alright, this was kind of a big giant review of what we've done for the last like 5 lessons. So we started doing this on lesson 2 of this unit. The last part that we're going to do today is just kind of talk about like how to write a rational function when we know some of the key features on it. It kind of feels like putting a puzzle together, like putting together the little pieces that go here and here and here. So we look at the first question. I actually think this first one was the hardest one out of all of them when I did them. The ones on the back I was like, oh, well that's easy. Oh, well that's easy. Alright, first thing we're told is we have vertical asymptotes at negative 1 and positive 1. What do the vertical asymptote, what part of an equation do the vertical asymptotes affect? The denominator. Okay, so I'm going to just remind myself that this affects the denominator. Okay, we have a horizontal asymptote at y equals 2. So based on the fact that it's y equals 2, that basically tells me it's not a bigger on top, because it's not a slanted. It's not a bigger on bottom, because if it was bigger on bottom, we would get a 0. So this one has to be one where the exponents are the same on the top and bottom in order to get a y equals 2. Exponents have to be the same. Exponents are the same. And that's how we got that divide coefficients and got a 2 right here. And then the function has a y-intercept at 0, 6. Okay, remember a y-intercept is basically when you plug in 0 for x, we would get an answer of 6. So I'm going to start kind of puzzle piecing this one together. And anytime we write an equation, we're actually just writing one possible answer. There's so many different possible answers you can get. I usually just write the most basic one. So I'm going to start just by obviously making it a function. I definitely want to say y equals. Okay. The one thing I can definitely set up right now is my denominator. Okay. What does my denominator have to have in order to get these two? X plus 1 and x minus 1. And when you do this, guys, you don't necessarily have to FOIL anything out. You can leave it in factored form, unless it helps you to FOIL it out. Sometimes FOILing it out helps me see, like, oh, okay, I know I need that. Okay, now thinking about the numerator, we need to make sure the numerator has a square in it. It has to have an x squared because we have an x squared on the bottom. Okay, I'm going to start by just putting an x squared up there. Now, on this one right here, would this one have a horizontal asymptote at 2? No. What would the horizontal asymptote be on this one? This one would be at 1. Leading coefficient of 1. If I multiplied this out, it would also have a leading coefficient of 1. So currently, it doesn't, but how can I adjust it to make the horizontal asymptote at 2? I can make the top at 2. Right. Okay. So thinking about what it is now, if you want to FOIL it out to kind of help yourself think about this a little, what's the last thing we have to make sure it has? The y-intercept is 0, 6. If I FOILed the bottom, what would I get? X squared minus 1. Very good. It's a difference of squares. So just checking the y-intercept right now, let's just check the y-intercept. Check y-intercept. If I were to plug in 0 for x, what would I get for the resulting y? I would get 0 over negative 1, which is 0. 0 over negative 1 is 0. You can divide. You just can't divide by 0. It can't be on the bottom. So does it have the right y-intercept right now? No. But we can add something to the top to make this have the correct y-intercept. What do we need to add to the top? A negative 6. A negative 6. I'm going to write it in and then we'll check it. A negative 6. Okay, again, checking our y-intercept. On the top, if I plug in 0 for x, I would have 2 times 0 squared minus 6. 2 times 0 squared minus 6. And on the bottom, I would have 0 squared minus 1. 0 squared minus 1, which would simplify to negative 6 over negative 1, which is 6. And that was the last thing we had to have match. Has the correct vertical asymptote, has the correct horizontal asymptote. It would have an EDC of 2, and it does have a y-intercept of 6 now. And again, this is just one possible answer. There's lots of possible answers. You can leave it in its factored form. You can leave it as the one we multiplied out. It doesn't really matter. They're both equivalent. All right, let's flip it to the back. We've got a few more of those. We're going to puzzle together. Okay, reading through it real quick, has vertical asymptotes at x equals negative 4 and x equals 8. It has x-intercepts at negative 2, 0, and 4, 0. And it has a y-intercept at 0, 2. So just thinking about what some of these would affect. What's the vertical asymptote going to affect? The denominator. It affects the denominator. What about x-intercepts? What does that affect? That does affect the numerator. Yeah, it's remember we always say, oh, that's when the numerator equals 0. So this one's going to affect the numerator. And then the last one, the y-intercept, that's one that we'll have to check by basically plugging in 0 and seeing what we get once we do these. And if we don't get the right number, we can always adjust our function. So I'm going to set up what I know about it so far. Okay, starting with the vertical asymptotes. That's going to affect my denominator. What two factors would be in my denominator then? X plus 4 and x minus 8. Good. Okay, and then similar with the numerator, these two came from the numerator. That would basically be two different factors in the numerator. What would be my two factors in my numerator? I have to write the whole factor. X plus 2 and x minus 4. Very good. As this negative 2 came from setting this y equal to 0 and solving it. And that's how we got negative 2. This positive 4 came from setting this equal to 0 and solving it. Now, I need to check the y-intercept now, and then I can adjust if needed, like add a number. What does it need to be? It needs to be 2. Alright, let's check that y-intercept, see what we get. If I plug in 0, on the top I'll have 0 plus 2, which is a 2. 0 minus 4, which is a negative 4. And then 0 plus 4, which is a 4. 0 minus 8, which is a negative 8. That would become negative 8 over negative 32. Right. Which would turn into 1/4. So is it the right y-intercept right now? No. Okay. But we can kind of play around with this. We can actually see exactly what the top needs to be. If we need to have our y-intercept equal to 2, what would this number need to be? It would need to be a negative 64. Right. Needs to be negative 64. Because if that's a negative 64, then negative 64 divided by negative 32 would give me this 2. So what can I add to the top, or what can I write in on the top so that I end up with negative 64 on the top? A coefficient of 8. I'm going to write it in, and then we can check one more time to make sure we got the right one. Alright, checking that y-intercept again. On the top, if we plug in 0, we'll have an 8. We'll have a 0 plus 2, which is 2. We'll have a 0 minus 4, which is negative 4. And then we'll have 0 plus 4, which is a 4, and 0 minus 8, which is negative 8. This would be negative 8 times 8, which is negative 64. And on the bottom, a negative 32, which would simplify to 2. Officially has the correct y-intercept. And they didn't mention anything about what the horizontal asymptote needed to be or anything like that, so I'm not even going to worry about that. But it does have the correct y-intercept now. It would have the correct x-intercepts. These two guys, when you solve them, would give you these two, and the two correct vertical asymptotes. So again, kind of just like a little puzzle you're having to put together. And again, you don't need to FOIL it out. That just wastes time, but you can if you want to. Getting the hang of it? Alright, looking at the next one. Alright. Function as a whole at x equals negative 1. Okay. Vertical asymptote at x equals negative 2, and a horizontal asymptote at y equals 0. What does a whole tell me about the graph? That something canceled from the top and bottom. What specific factor would have been in the top and bottom that canceled? X plus 1, right. X plus 1 will be in the top and bottom. And it has to be in the top and bottom because it would have had to have canceled from the top and bottom to create that hole in the graph. Vertical asymptote at x equals negative 2, what's that going to affect? Denominator again. Good. Affects the denominator. Okay, and then horizontal asymptote at y equals 0. Horizontal asymptote at y equals 0. The fact that it's y equals 0, think about your BoboBots eats DC. Which one will give you 0? It needs to be bigger on the bottom. Yes, right. Degree must be bigger on bottom. bigger on, it doesn't say anything about the x-intercepts, it didn't say anything about a y-intercept, so those don't matter. Okay, let's fill in what we know. Obviously it still needs to be a function, so I'm going to put y equals, I'm going to set up my fraction. I know that there's going to be an x plus 1 that's going to cancel from the top and bottom. So I'm going to write in that x plus 1 on the top and the x plus 1 on the bottom. Okay, what else is going to be in there? I can see this vertical asymptote will affect the denominator. What's going to specifically be in the denominator? X plus 2. Okay. And then looking at it, would this degree be bigger on the bottom as it is now? What about if this factor canceled? Is it still bigger on the bottom? Yeah, still bigger on the bottom. The top doesn't even have a variable. The bottom has it x plus 2, so it would be technically 1 over x plus 2, which is still bigger on bottom. So do we need to add anything to it? No, it's good. It's good the way it is. We would have a hole at x plus 1 where that canceled. You would have one vertical asymptote left over then at x equals negative 2. And you would have one term on the bottom, nothing on the top, so it is bigger on bottom. Perfect the way it is. We didn't have to add anything. Alright, last one. Even though there's a lot going on the last one, I actually thought the last one was kind of easy. Alright. Has a one vertical asymptote at x equals negative 3 over 2. A horizontal asymptote at y equals 1/2. A hole at x equals negative 1/2. And an x-intercept at x equals 3 and a y-intercept at y equals negative 1. And what does a vertical asymptote affect? Which part of the function? The bottom. Yep, that's going to affect our denominator. Oh, I almost wrote denominator. Denominator. Okay, horizontal asymptote, the fact that we got y equals 1/2 and we didn't get a slant, we didn't get 0, what does that tell me about the degree of the top and bottom? Yes, the degree would be the same on the top and bottom. So however many variables you have on the top, you have to have those on the bottom. Exponents have to be the same so that we can divide our coefficients and get a 1 over 2. Okay, a hole at x equals negative 1/2 tells me that there was some factor that canceled from the top and bottom. Can we tell what factor that is? 2x plus 1 canceled on the top and bottom. Cancels on top and bottom. If you're not sure if it's 2x plus 1, you can always check real quick. If you were to take this and set it equal to 0 and solve it, would you get negative 1/2? Double check. 2x plus 1 equals 0. 2x equals negative 1. Yes. Okay, so that is the correct factor for the whole. X-intercept at x equals 3. What does that affect? Which part of the graph? The numerator. Affects numerator. And then lastly, there is a y-intercept of negative 1, which we'll just have to check at the end, and if not, we can always adjust it. Alright, let's start setting up what we know. Y equals. Vertical asymptote at x equals negative 3 over 2. Can we tell what factor that would be? 2x plus 3. Let's write it down and then double check it. 2x plus 3. If we were to take that, set it equal to 0 and solve it, that would be 2x equals negative 3. Which means x equals negative 3 over 2. Very good. 2x plus 3 does go in our denominator then. Oops, I wrote a 1. It should be a 3. 2x plus 3. What factor, ugh, my bad. What factor canceled from the top and bottom? 2x plus 1, we wrote that down earlier. 2x plus 1 needs to be on the top and bottom in order to cancel to give us a hole on the graph. What else can we write in? X minus 3 is going to affect the numerator, give us that x-intercept. X minus 3. Okay. And then horizontal asymptote and y-intercept. So the last two we need to check on, does it have the right horizontal asymptote? Does it have the right y-intercept? And we can do that by basically looking at the function now. If those 2x plus 1's canceled, what equation would that create? Right, we would have just an x minus 3 over 2x plus 3. So we need to check if this has the right horizontal asymptote and if this has the right y-intercept. Even though this is the original function, this is what we need to check. Does this have the right horizontal asymptote? Yep, exponents are the same, and you would divide your leading coefficient, giving you a 1 over 2. So the horizontal asymptote's fine, the way it is now. And then if I found the y-intercept, let's check that y-intercept. Check y-intercept. If I plug in 0, I would get 0 minus 3 over 2 times 0 plus 3, which would simplify to negative 3 over positive 3, which is negative 1. Is that the right y-intercept, or do we need to adjust it? That's the right y-intercept. What are we circling for our final answer then? The pink one or the black one? The black one, right. The black one is the one that shows that that whole canceled out. Very good. Alright.